Powers represent repeated multiplication. Just like it says right there. Which means 7 to the third means 7 times 7 times 7. Which is, of course, 343. Now, don't feel bad. At least one of you, even in this honors class, at some point, is going to blurt out the answer, what's 7 to the third? And some of you are going to say 21. It's okay. Or I'll say, what's 6 squared? Some of you will say 12. It's okay. It's automatic. You will do that. I will be very nice about it the first 10 times. After that, I will point and laugh. Okay? All right. Some of you forget how to do this on your calculator. That's good, because in this unit, you will almost never do this on your calculator, because we are getting away from evaluating things and getting into theoretical stuff. But just to remind you, to evaluate this on your calculator, you are looking for either the X with a little Y button, the Y with the little X button, this little mountain, which is called a caret, or on the newest calculators for the dumbest people, not spelt like what's up, Doc? C-A-R-E-T. That's what the name of that punctuation mark is. You know, when you're writing in a piece of page like the math teacher, and then you remember you're talking about me, so you have to remember that the gorgeous math teacher, and then you got to put that little word in there. That piece of punctuation is called a caret. C-A-R-E-T. See how much stuff you learn in this class? I know, right? Anyway. Or on the newest calculators for the people that understand math the least, this is so embarrassing to math teachers. I couldn't believe it when I saw it for the first time. X with a little blank square. Because too many letters on the calculator is apparently too confusing.
There's also X2.
No, that's X squared, though. That's not any exponent. X with the little 2 only squares it.
But I can edit it. So that
Okay. And of course, that's how you do these. You would go 7, then that button, then 3. And you would get your answer. You're all capable of doing that. So, now, the next thing we have to talk about is remind you of the proper terminology of these things. Because, of course, you need to know that going forward. It seemed easy in the 9th grade. Many of you have already done everything I've done here. If you were in my 9th grade class, the next day or two, you already know everything. If you were not, I can't guarantee it, so I go over it all. We start with the base, and I highlight the base. The base is, there are 2 ways you can answer this next question that I am going to give you. What is the base? That's the question I have asked. Formulate an answer for me. What is the base? Okay, so you named it. You gave me a definition of what it looks like, right? It's the big number. Excellent. Okay. What did you say? The number that is multiplied, the repeating number. Excellent. And then 2 other people said 7, which is fine too, because in this case, the base is indeed 7. So of those 3 definitions, I'm going to use all 3 of them. One is the mathematical definition. That's what Harmon gave me. The base is the thing, and I'm not saying number because it doesn't always have to be a number, the thing that's repeated. So in this case, it's 7. But it's also, I'm going to write this in red because this is different. It's not the mathematical definition. It's a physical definition. Okay? And the physical definition, where you find the base on the page, is the, and I don't want to say big number, because in this case it's a big number, but it doesn't need to be a number. It's the thing. And this is weird because it's not a good way to make a definition. Of course, you all remember from early English classes. What is the one word you're not allowed to use in the definition of something? No. The word that you're defining, right? You can't use the word that you're defining. So I'm going to use a word. The second sin of making definitions is using another word that needs definition to define it. Do you know what I'm saying? For example, if you were defining the word pachyderm, you might say a word given to large four-legged animals native to Africa. Right?
Which part of it needs explanation now?
Well, I'm that you might say that. Or you could say this. Pachyderm, a word for humongous quadruped animals living in Africa. Now, what is wrong with the second definition? You would need to define quadruped, and you might even need to defend humongous to some people, or define humongous to some people. Quadruped means four-legged. Quad, four, ped, legs. We're bipeds because we have two legs. Bipedal, not bipedal.
But
Oh, that's what you said to
four legs.
when he went off to his friends. Biped.
Oh my God. All right. The thing that is left of, and please notice that I've capitalized left, the thing that is left of an exponent. And why is that definition not so hot? Because you got to define exponent.
You could say small things.
Okay? Now, next, the exponent, which I have in blue. In this case, it is 3, right? What's the mathematical definition of an exponent? Right. The number of bases. And where does it physically live? It's a superscript, which is a word that needs definition, right? What does superscript mean? You've all taken Science 10. Subscripts were where? Down below, AL2, O3. So where would a superscript go? Up, right? Superscript, that's to the right of a base. Now, look at those two definitions carefully. The base is whatever is directly to the left of an exponent. And an exponent is whatever is directly to the right of a base. So let me ask you this before we go any further. What's the base there? No. 2. Why?
Because the entire expression is negative?
That's... Yes, the negative is not left of the exponent. The negative is left of the base. Everybody understand? So the base there is 2. Now what is the base? Negative 2. Okay?
So when you write it down, hold up 1 minute. When you write it down, base and exponent on this little thing, then it says -3.
How about we wait till we get down there, Jayla?
Okay.
Because I don't want you filling out that little thing yet. Because there's lots of stuff that I'm going to explain before you even get to that table. I am aware that it's too late. A great many people have already started filling out the table. Good. So, this is different than this. Okay? All right. Back to here. The power is the whole thing. A power is a base and an exponent. And it's read as base, whatever the base is, to the whatever the power is. Oh, not the power, idiot. To the exponent. And after the exponent, we put usually th, but second and third, no. But then fourth, fifth, sixth, right? The exponent, th. Everybody with me? Some exponents get special names. Which ones? That one. That's squared. And what's the other one? That one. That's cubed. Everybody else doesn't get a special name. There's no name for fourth except fourth. Everybody cool? This is also where we get the expression in English, the nth degree, which means till infinity. Nth being the exponent. Okay? Some of you may have heard that expression. If you haven't, again, you just learned something new again. Woo! Somebody stop me. Fill in the table. Jalem's already had a head start. So is his little crew over here, I bet. Rules with an iron fist, eh, Jalem?
Yeah, a black fist.
Well, but it's still iron. Go. In the 9th grade, you had to do exponents with numbers and a base. If you were in my class, you went to the next level and you had variable bases. I don't know if Mr. Hirschman did variable bases or not, or if he only used numbers. So until you get down to here, everybody should be good. But when you get to that, some of you might be a little, okay. But you're smart kids, you'll figure it out. Go. I'm going to push pause on the recording. Actually, I lie. I'm not. I'm just going to turn off the screen and fill in the chart, and it will continue to record. If you are already past x cubed, that's fine. If you're not at x cubed yet, I want you to stop when you get to x cubed. I'll make sure everybody's doing this right because there's a couple of things in there that we need to mention. All right. So everybody should be good down to there. Check your work. Make sure you've done it right. There's a couple of things I want to call your attention to. One is the line which Jalem was talking about earlier. That line right there. The base is 3, so only the 3 repeats. 3 times 3 times 3 is 27. But that negative in front says that everything that comes after it is negative until the next operation. So that 27 has to be negative. Everybody cool? All right. Next one. This line needs to be discussed. It's not highlighting green because my computer stinks. What is different about the green line? The negative is part of the base. So not only the 5 repeats, so does the negative. So it is negative 5 times negative 5, which gets me positive 25. Now, here is where we have to take a moment to discuss. What would negative 3 cubed be? Is the negative part of the base now? Yes. It's still negative 27. Because negative times a negative times a negative. Right? What would negative 5 squared be?
That one right there.
Negative 25. Because in this case, the negative does not repeat. Is everybody with me? Oh, working on your French too. Très bien. Oh. La classe prochaine? Oui. Très bien. So, evaluating these two, of course, you had to use your calculator so I can check and make sure that everybody can do that, right? 32,768 and 7,776. Those two numbers are not 32768 and 7776. Those are not numbers. Those are lists of digits. The next line. Why is it still negative, even though the base is part of the negative? Or even though the negative is part of the base?
It's an odd number of negatives.
Because it's an odd number of negatives. Well done. And 10 to the third, excellent. And then, of course, we get down to x cubed. Now, some of you will not have done exponents with variable bases, but most of you have. Even if you haven't, you should have been able to figure it out, right? Because the base lives to the left of the exponent. The base is what's repeated. The exponent is how many times you repeat it. So x, x, x. The only thing you can't do is this. You cannot evaluate a variable exponent. All right? You have to leave it like that. And this is what we are going to do from the 10th grade onwards. Very rarely will you evaluate that. Everybody cool? All right. And then the rest you should be able to fill out. How do I get with a positive base and a positive exponent to negative 32?
There must be a negative in front of it.
Has to be a negative in front of it. So negative 2 to the 5th. Does that work? That works, right? Why does it have to be that? Because doesn't that also get me negative 32? Yeah. So why is that wrong, but that right? Figure it out. Talk to your neighbor. Kian. This base says 2. If I put brackets around there, what's the base become? Negative 2. So how would I write it out? It would be negative, and then what? 5 2s. Everybody good? All right. Now, 2 spots, they both equal 9. There's 4 ways to do these 2 spots. Who wants to give me one of them?
3 times
3 times 3. So I could have 3 as a base, 2 as an exponent, and do 3 times 3, correct? Which would make the power 3 squared. Everyone agree? Excellent. What's another way I could have done it? I could make, so what would the power look like? Bracket negative 3 squared. So what would the base be? Negative 3. And what would the power be? 2. And what would it look like? Negative 3 and negative 3. Right?
It could also be base of 9 and exponent 1.
So now, I could also do base of 9 with a power of 1.
The other way around as well.
9, 1, 9. Right? Is there another way I could do it?
Can you make the exponent negative? Or is that a whole different thing?
It's a whole different thing.
Can you make a base 1 exponent? No.
There is another way to do it with exponents and bases. I'm just seeing if any of you know it. Because I know I didn't teach it. So I'm seeing if anybody knows it from somewhere else. No? Okay, I'm going to leave it alone. Because we'll come back to it later when I actually get to it. All right. And what about this row? What's the base? Negative 4. What's the exponent? So it's negative 4. How many times? 6 times. Now, if negative 4 repeats an even amount of times, then my answer should be what? Positive. Except, is it?
No,
Why?
the extra negative symbol.
Because there's an extra negative out in front. So what's the answer? Negative 4,096. Everybody good? And then, of course, the bottom. What's the base? What's the exponent? No. 1. Because we never write an exponent of 1. Never written. Always there.
Oh, no, that's great.
What?
It's always stalking.
It is. Now, at the bottom of this page, just to remind you, write a couple of things. Okay? Negative x squared will still be negative. Negative x squared will be positive. Negative x cubed will be what? Negative. Negative x cubed will be what? Negative. And negative x to the 4th will be what? Positive. And finally, what would negative x to the 4th be? Negative. Everybody good? We all remember this stuff? Everybody used exponents? Everybody did variable exponents? You've all had a base of a letter, of a variable? Excellent. Turn the page over to 95. Let's talk about exponent laws. All of you know this. 2 squared times 2 cubed. What is that really? Why?
Exponent laws, when you're multiplying two exponent or two powers, you gotta put the exponents together.
Okay, that's telling me what you're doing. That's not telling me why.
Oh, okay.
Why? What?
Because if it's the same base and you just add
Again, you're telling me what to do. I want to know why.
math.
No, not because math.
It's the same thing as adding
What is that really?
It's 2
Oh, bed max.
to the power.
That is 2 times 2. What is that really? 2 times 2 times 2. What does that symbol mean? times. So what would go right there? No. A times.
It's the same thing.
2 times 2 times 2 times 2 times 2. 5 2's all multiplied. 2 to the 5th. Now, what do you do when you see this? This is why it works. What do you do? What's the rule?
You add, if it's in the same base, then you add the exponent.
Right. So now we'll write out the rule. X to the m times x to the n, same base, equals x to the m plus n. That's the rule. You all know that from the 9th grade. Yeah? Yeah. So what's the dividing one?
Minus it.
2 to the 5th divided by 2 to the 3rd. That can be written in another way, can't it?
Fraction.
Right, as a fraction. You're on fire today, Jalen. What's that really mean? Two times 2 times 2 times 2 times 2 over what? 2 times 2 times 2. What do you get to do every time you have the same thing on the top and the bottom of a fraction? You get to cancel it out. Why? Everybody says, I'm going to cancel. Why? I know that's how you learned it, but that doesn't help you in higher level math. That helps you up till now. Right? Your previous teachers would show you how to do stuff. And don't worry, they always told you why, but you stopped paying attention as soon as you learned how. So why? Why do I get to do that, that, and that? What math is that? Right. So that's 2 divided by 2, yeah? What is 2 divided by 2? 1. What is 1 times anything? Do we ever write 1 times anything? No. So I don't need that because it's 1. I don't need that because it's 1. I don't need that because it's 1. That's why it works. What's left over? 2 times 2. No math guy would write 2 times 2 because they're lazy. What would they write? 2 squared. So what's the law? X to the m over x to the n is x to the m minus n. Gouda? Also something you already knew. Go down to number 3. What would that look like? Well, you need it. That is the wrong word there. That should say power. Raising a power to an exponent. So that would be 2 squared. There's a power, right? How do you know it's a power? Because it's a base and an exponent. And then I'm going to raise that to another power, to an exponent. So what is that really? What's the base here? The base is 2 squared. So this is really 2 squared times 2 squared times 2 squared, yes? Which is really 2 times 2 times 2 times 2 times 2 times 2, which is 2 to the power of 6. So what's the shortcut? You multiply. X to the m to the n equals x to the m times n. Now I need to stop there for a moment because right about here is where you guys start forgetting stuff. Because even though this makes perfect sense, you often start screwing up at number 3. Don't write down what I'm about to write down, just look. 2, as soon as my computer starts writing again, we all know what 2 cubed is. What is it? 2 times 2 times 2, which is 8, correct? Everyone agrees? Right. We all know what x cubed is, right? What's that? X times x times x. And we can't evaluate it, can we? Excellent. Okay. What's the base in the first line? What's the base in the second line? X. Excellent.
Excellent.
Now what's the base?
2x.
So what does that mean? 2x how many times? Thrice. Yes, it is. Thrice is a word. No, thrice means 3 times, like twice means 2 times. Okay. You know, it would be funny if you named your third kid Thrice. No, he's your third kid. You had a kid, and then you had a kid a second time, which means you had a kid twice. Then your third kid, that's your third kid, so you had him. You've had kids thrice times.
Yeah, I'm really bad.
Are any of you in families with 3 children? At least? Well, so according to Jalem, he's really bad if he has 3 children. All right, so you guys are smart. What is this answer? What is this answer?
8x.
8x cubed. That puts all 3 of the first laws together. Is everybody good? All right. Now, let's go down to number 4. You did this in grade 9. A fraction base. 2 over 5 squared. What's the base? It'll show up in a second. 2/5, which means what? 2/5 times what? 2/5. You got to make it happen twice, yes? So the numerator is 2 squared. The denominator is 5 squared to get 4 over 25, yes? So what's the law? X over y to the m becomes what? xm over ym. Now the next mistake that you guys make is you focus in on one exponent law and you forget about all the others. That's what I just did over here. That's why I did this. Okay? So what if I gave you something that looked like this? Don't write this down. 2/3 squared. What would that be? You can evaluate that in your head. What would it be? 4 over 9. Yes? Right? Okay. Then what would 2x over 3y squared be? 4x squared over 9y squared. Excellent. Good job. And up to there, you should be pretty cool. An exponent of 0. Everybody knows this one. Everybody says it. What is 7 to the 0?
0.
No. 1. Everybody knows that one, right? So what's the law? X to the 0 equals 1. Is math ever that simple?
No.
Of course not. First of all, I want to know why. Can anybody explain to me why this is true? Or did you stop listening when the teacher said, anything to the 0 power is 1? That's when you all stopped listening. So when I write this down, -1 to the 0, what's the answer? See, you don't actually know how to do it. What's the answer to that? -1. What is the answer to this?
Is it -1?
1.
How do you know? That's hard.
Why? I'm asking you, why?
I don't know. You know?
Of course I know. Why is this guy negative and this guy positive? It all has to do with the law that you all memorized. It all has to do with that law. What's the difference between the blue one and the yellow one?
Oh, there's brackets.
Brackets are a big part of it. What do those brackets do?
Oh, it makes only the one negative. Oh, I see what's going on.
In the yellow line, what's the base? 1. And any base to the 0 power is what?
Oh, hey.
1. So 1 to the 0 is positive 1. But that negative,
Makes a whole thing.
now how is that different in the blue one?
Because it's only the negative. Only the base. Only the base.
The negative is part of the base. Everybody with me? Now, the reason most of you screw that up is because you didn't bother to listen when your teacher explained why it works. Okay? Here is why it works. What is 2 squared? 4. Agreed? What is 2 to the 1? 2. What is the relationship between 4 and 2? Half? What else could it be? Pardon? It's changing exponent. I shouldn't have used 2 and 4. But it's too late now. Exponents going up are multiplying, yes? So what must they be getting smaller? Division. So this is division, yes? So to get from 2 to the second, which is 4, to 2 to the first, I would have had to divide by 2, correct? So what's the next logical exponent? 2 to the 0. What should I do to this 2? What's 2 divided by 2? 1. That's why it works. If you don't understand that, let me show you this version of it. 2 cubed over 2 cubed. What is that really? It's really 2 times 2 times 2 over 2 times 2 times 2, yes? Cancel, cancel, cancel. 1 over 1, which is 1. It's not nothing, it's 1. So that's why x to the 0 is 1. Is everybody cool with that? All right. Now, turn the page over. What's different about number 6? Number 6 has something totally different than 1, 2, 3, 4, 5. What is it?
You got 2 bases.
2 bases. So, I wrote it right here. xy cubed. What's the base there? xy, which means what? xy has to repeat how many times? 3 times. xy, xy, xy. How many x's do I have there? 3. X cubed. How many y's do I have there? 3. Y cubed. So what's the rule? xy to the m equals x to the m, y to the m. Can I forget about rules 1, 2, 3, 4, 5? No, I cannot. So I need to remind you of something over here. Again, don't write it down, just pay attention. X squared, y to the 4th, all to the 3rd. What's that? Remember, you know that outside exponent has to go to everything inside, but according to exponent law 3, isn't there something else that has to happen there? You have to multiply. You can't forget about exponent law 1, 2, 3, 4 when you're doing exponent law 6. Okay? So what would this really be?
X 6 Y 12.
12. And then, of course, you would make it xy to the 18th, right? exponents? Yes or no question?
Yeah.
No, of course not. Why not?
So they're not the same base.
Because they're not the same base.
That law doesn't apply.
That law only applies to the same base. And finally, the thing that is new in grade 10, supposed to be new in grade 10. Nobody in grade 9 is supposed to have done negative exponents. Kids in my class did negative exponents. I don't know about anybody else. So, let's discuss it. So what would a negative exponent look like? 2 to the negative 3. Everybody cool with that? Base with the negative exponent. What does that mean? In math, what do you do with the base when you see an exponent? You do 3 bases, right? How do I write 2 3 times negatively? You cannot do it, right? Now, those of you that were in my class already know that what the answer to this is, right? Or you did know it and maybe you forgot it. For a change, I'm going to show you the way you should learn math. You should learn why first before you learn any shortcuts. So let's talk about why we can get a law from this. What is 2 squared? We've already done it. It's 4, correct? Next logical exponent going down, because I need to get to the negatives, don't I? 2, 1, we know that is 2. 2 to the 0, we know that is 1, because I continue to divide by 2, correct? What is the next logical exponent? Negative 1. So what is the next logical thing to do here? What have I done all the way down? So what is this? 1 divided by 2. What is the next logical exponent? Negative 2. So what do I do here? I divide by 2. What's half of a half? A fourth. What is the next logical exponent? 2 to the negative 3. What's half of a quarter? An eighth. Now, please notice you see the pattern. What would 2 cubed be? 8. Please notice that you see the pattern. What is it? What is it? Two to the third was 8. 2 to the negative 3 was 1/8. 2 to the squared was 4. 2 to the negative 2 was 1/4. 2 to the 1 is 2. 2 to the negative 1 is 1/2. What do you notice about the highlighting? It's the same number. What is this number really supposed to be written as, but we don't write it because we're too lazy? No, 8 over 1. What is this number really, but we don't write it because we're too lazy? What is this number really? So what happens with negative exponents? Yeah, there's a math term for that. What do you... Yeah! Negative exponents reciprocate. Okay? Now, this seems easy, right? 3 words. Negative exponents reciprocate. The law, x to the negative m equals 1 over x to the positive m. Because positive exponents make sense, don't they? We just write the number 3 times. So this obviously becomes 1 over 2 to the positive 3, which is 1 over 2 times 2 times 2, which is 1 over 8. Everybody has no problem with that. But they forget the previous 6 rules. And they forget a bunch of other stuff, even though this is a pretty simple rule, isn't it? So we're going to take a little bit of time with this one, because this one causes kids problems. We're going to start with a simple one, like we already had. We'll start 2 to the negative 3. What is that? I see a negative exponent. I know that makes no sense. I know I can't have a negative exponent. So I'm going to reciprocate it. 1 over 2 to the positive 3, which does make sense. 1 over 8. Yeah? Okay. Now let's start doing some mix-ups with this law. Remember, I am using the proper terminology of base and exponent on purpose. What would this be? What part of that makes no sense to you?
Negative 1 over 8.
So, Jalem says it's negative 1/8. Is he right?
Yeah.
He is. Why?
Because that negative transfers over.
Because that negative transfers over. But I just said earlier you can't have a negative exponent. Do I have a negative exponent anywhere in my answer? No. I have a negative base. Are negative bases okay? Sure they are. What would this be?
That's not okay.
It's not okay. Why?
It's too negative.
The negative 2 is allowed. It's a base. What's not allowed there? Negative 3. What happens to negative exponents? They reciprocate. So right now, this is really that, isn't it? So reciprocate it. What is it? 1 over negative 2 to what power?
3. Negative 3.
Oh, 3.
Oh, regular 3.
Because it's in the brackets, it stays safe with the bracket.
So what is this answer? Still negative 1/8. Because negative 2 times negative 2 times negative 2 is still a negative number. Negative bases are allowed. Everybody good still? Okay. What about this?
I can't remember. Oh yeah, 16.
It's 1 over 2 to the positive 4, which is 1 over 16, so it's positives. Everybody still cool?
Wait, the exponent's not negative, so it doesn't need to reciprocate.
Oh yeah, that was supposed to be a negative. Sorry, my fault.
Oh really?
There should have been a negative there. Sorry, guys. But anyway, everyone's cool. I'm trying to keep with this because of where I'm going. Everybody still good? Okay. Now, I'm going to do the thing that really always, this is where things go haywire. What is this?
What is that?
It's 1 over 2 to the negative 3.
Negative 1.
No. What does a negative exponent do?
It reciprocates.
Oh, it's not reciprocated.
So that is 2 cubed, which is positive 8. As Green just said quietly, minding her own business, kicking ass, and taking names. Everybody understand? Everybody still cool? It reciprocates. It has to move. So, what then is this? X over y to the negative 4.
Y over x to the 4.
Y over x to the positive 4, which is y to the 4th over x to the 4th. That is where kids start really getting in trouble. All of this is that one law. Is everybody cool? Yeah? Everybody is good? Okay, listen. We've got 10 minutes left in class. Page 97 and 98 and 99 and 100. Now on 99 and 100, you can quite plainly see I've circled some letters, yes? You only need to do the circled ones. But when I go over them tomorrow, let's say you get 4 or 5 of the circled ones wrong. What should you do tomorrow night? Do the ones that aren't circled to make sure. And I'll go over them the next day. Because believe it or not, this is the 17th year I've been teaching Math 10. Guess what? Usually the second worst test of the year done by my honors Math 10 students is the test with exponents. Measurement. Yeah. Does everybody hear me? It's only 7 rules. And yet, even in the 10th grade, I can write them in such a way that you, the best and brightest math students in the school, are getting your worst marks on it. Do you all understand me? They are tricky. They are easy to use, but they are complex. Understand? It's only 6 rules. It shouldn't be that hard. And they all make perfect sense if you write them down. Everybody with me? You guys go. We'll come back to this tomorrow, and we'll be going over your cumulative test tomorrow. Did we go over the trig test?
Yeah.
You haven't had your trig test back, have you? I gave it back and then took it back. So we went over it? We just looked at it. Okay, so tomorrow we'll be going over trig tests, cumulative tests, and making sure our exponents are up to snuff. Okay? Okay. If you can't read the printing, like it photocopied badly, just take a best guess because the laws are the laws. All right?